All right, let's begin. I told you to go home, revise, because I said I was going to test your knowledge again. So let's begin. Continuous probability. What is continuous probability? Can I please have Rex? It is what? I just want to know what continuous is. What's continuous? It is? Height is an example of continuous, but give me a definition, Amir. It is an uncountable variable. Height was one of them because you can have in-betweeners. It's not definite. It's not like a t-shirt. So yes, height is one. So I'm going to write here. Height. And it means uncountable. Height. Give me another example. Yes, Steven. So I can't hear you. Something that can be measured. So give me an example. Time, length, weight, speed. All these are everything that is measurable. Hence why you can't count it individually. Unlike rolling a dice, heads or tails, t-shirt sizes, small, medium, large. Yeah? These are all measurable, so hence you can have length, width, area, volume. They're all continuous variables.
She told everyone.
Yes, Josh. All right, so we got the idea. We got the idea of what continuous is. These are the variables, Josh. These are the variables that are uncountable or measurable, and because of that, we couldn't find the probability. Because it's between an interval, that's much easier to do. You can't choose one, and you can't say, what's the chance of choosing someone who's exactly, I don't know, gets to school exactly 8 hours and 2 seconds. You know, it's hard to measure. It's one out of what? Out of infinity. You know, whereas rolling a dice, I can say, what's the chance of getting... Rolling a dice, you can count the number of outcomes you have. Height, you can't have an outcome. You don't know what the number of outcomes is. It's infinite, right? That's why for continuous probability specifically, when you have these kind of variables, then there had to be a condition. Now, what was that condition called again, Sebi? Yeah, there are two conditions. What was that under? What was it called? Good. Probability density function. So I'll write it here. Probability density function is what you need. That is what you want. Now, why do you want a probability density function in order to model probability? Is because if you wanted to model it, it has to make sense. Now, in order for it to make sense, to use a function to model it, it has to have two conditions. Now, what were those two conditions? Name me one. Can I please have Percy? Good. Sum of all probabilities have to be 1. And because we know that a function represents, the area underneath the function represents the probability. So if you got, this is f of x, then the area underneath it, we can now call it probability. That's our theory. That's what we wanted. We said intervals. Intervals allows us to find the probability. And in order for that to work, the area has to sum up to 1. The probability adds up to 1. So that makes sense. First condition. Area under the curve has to add up to 1. What's condition number 2, Jack?
Has to be greater or can't be negative.
Good. The function cannot be negative, so f of x greater than or equal to 0. It has to be positive. Why does it have to be positive, David? You can't have negative probability because remember the area represents the probability. So if you have negative area, it means you have negative probability. That's impossible to have. That's why you need these two conditions. So once it's PDF function, then that means whatever curve you can think of, whatever that function is, if it's a probability density function, you can now find the probability of any continuous variable, because it could be speed, weight, height, time. In exercise chapter 15, that's the first exercise that you learn, right? Then it moves into everything else you learned in chapter 13. So 15b, 15c, you needed to find the expected value, the variance, your standard deviation. Let's go back. How do you find your expected value? What's the theory for the expected value from chapter 13? Can I please have Frankie? Fantastic. Sum of x times the probability is what you learned from chapter 13. So linking this to chapter 15, what is the formula for e of x? Can I please have Jonathan? Anti-diff sign, yes? Yep.
X times f of x, yes.
Fantastic. Because we already know integration of f of x is your probability. Integration means sum the area. So you're really just saying sum all the probabilities where you times x. That's the same thing what you're saying here. Sum all the probabilities times x. That's exactly what I'm doing. The thing that most students don't notice is if it's e of x, then that becomes x. If it's e of x squared, if I wrote e of x squared, then what is my formula? Can I please have Josh Nguyen? Yep. Fantastic. That's the only difference. You see, it's exactly the same. Whatever you have in here, then you just find the mean of that. So whatever those variables are, the variables times the probability gives you the mean. That's what you're really saying. So that now leads to the theory for variance. What's the formula or the theory for variance from chapter 13? Can I please have Gary? Say it again? No, that's for binomial. Yes, you're right. That is n times p times 1 minus p. That is for binomial. Chapter 14, binomial is only a specific type. It's not for continuous. This is a common mistake with a lot of students because there's so many formulas. That's why I don't want you to memorize. That's why I'm trying to teach you to see how it links to chapter 15. 15 is continuous. Remember, continuous cannot be this. Continuous, we talked about region. So every time it's region, it has to be area. If it's area, it has to be integration. So this is for binomial, chapter 15. That's correct. But I want to know the theory for variance. It's the one where I keep talking about the prediction, your actual score, and the differences. What is the formula, Mia? Fantastic. E, it's not times, it's E of x minus mu all squared. And that basically just means find the mean of your data, subtract my prediction, squaring it. That just means find the mean. So find my average error is what you're really doing. Find how bad is my error of prediction. Yep. Yep. Okay, so you're saying find your error of prediction, and so that means if this is true, if that's the theory, then E of x minus mu squared, see for chapter 15, it's the same thing. If you said E of x, that becomes x times probability. E of x squared means x squared times the probability. Then E of x minus mu squared, the formula, you don't have to memorize this. They all come from chapter 13. It would have to equal to what, Adam? Oh yeah, that could work too. E to the... I'm just wanting to know the formula for the integration, chapter 15, theoretically, how do I find the variance in chapter 15? Yep.
Leaving from positive infinity, bracket x minus mu bracket squared times x.
Yeah. See, for me, these are all the theories. Chapter 13, everything that you've been saying so far is chapter 13. E of x squared, the only difference is you're converting it to area. Area means integration. So that's why you know. You know the student understands it when you do a question it says continuous and then you see something that's not integration. If it's not integration, then how are you finding the probability? It has to be the area. All I'm saying here is E just means the mean. Mean, you already told me chapter 13 was the sum of all x variables times the probability. That's what I did. E of x means x times probability. E of x squared just means x squared times probability. E of x minus mu squared just means x minus mu squared times probability. It's the same thing throughout. Okay? Now this one was harder to compute with. That's why they gave you a computational formula for the variance. So what was a computational formula for variance? Chapter 13 again. What's a computational formula? Can I please have, who would I pick? Let's pick someone in the front row. Layla. Fantastic. This is your computational formula. And you see, if you were to change this to continuous, chapter 15, E of x squared you already know. What's that? Minus E of x you already know too. Whatever that answer is, square it. That's how you do in chapter 15. So there's nothing to memorize. Whatever you learned in chapter 13, it's the same thing. Doing the same theories throughout. It's just one is discrete, one's continuous. One has an area, one doesn't. Okay? So, that summarizes for variance. So that means once you know variance, you can then find your standard deviation. Okay? Which is the square root of our variance. Okay? So, every session I've just been trying to recap to you. So you can see the time. What you do in chapter 13 is the theory in chapter 14, 15. Okay? Whatever you understand now for chapter 15 is going to be the theory for chapter 16. So 16. Normal distribution. Let's recap what we learned. Chapter 16. Chapter 16. What did we learn in chapter 16? Can I please have... pick Jack. What did we learn in chapter 16? Standard normal. Standard normal. It gives you an equation. They tell you f of x equals 1 over sigma times root 2 pi e to the negative half of x minus mu all over sigma squared. What is that? What is this? So we said standard normal. Got this graph, but what is this graph? Because we're studying this graph. That's what we're doing in chapter 16. What is this graph? What is the standard normal? Why is this so special? Someone describe to me, why is this so special? Can I please have Alice? Why is this so special? Good. So first part, this graph is symmetrical. That's what we like, symmetrical. But not only because it's symmetrical, something else, another two things. Why else do we like it? Sebi? The mean is 0. Mean is 0, that's why we call it standard normal. If it's not the standard normal, it doesn't mean the mean is at 0. Okay, so if it says normal distribution, it means the mean's not 0. If they say standard normal, the mean is at 0. What else? Why else do we like it? Mean is at 0, and what else do we like? Stephen, now? Good. Standard deviation is 1, which we use the sigma to respond to that. Okay, so a couple of things. A standard normal. Remember, chapter 16 is an example of chapter 15. You need a probability density function. Remember, I said you can have any curve. They found this curve. This curve is a probability density function, meaning the graph is 1 above the x-axis, which is true. This is f of x. Not only that, the mean is right at 0, right in the center. The spread, the width of it, standard deviation is 1. So it's perfect, which I haven't talked about the regions yet, but I'll do that today, about regions. Why you like standard deviation being 1. Okay? So we've got a symmetrical graph. I didn't draw it symmetrically, but it's symmetrical. It's above the x-axis. And we found the area from the left to negative infinity to infinity is equals to 1. That's why we like it. Okay, so we like it because area equals to 1 is a probability density function. So right here, it is PDF. So you can model it. You've got a curve, it's symmetrical, means at 0, and standard deviation is 1. Okay? Now, one more thing. What else did we learn in chapter 16? One extra thing. So I told you about the standard normal, you got these points, but in reality, you don't have these points. In reality, you can measure IQ, and your mean could be at 100. It might not be a standard deviation of 1. It could be a standard deviation of 5, 6. So, one extra property that you should learn in order to do 16A. What was that extra property? One more thing. Hint is transformations. What was that property, Luke? What was that property? One more thing. What else did we learn in chapter 16? Fantastic. You see, what you need to understand is when you say standard normal, you have to understand that this x-axis, we traditionally call it the z-axis. That's why they always refer, if you're doing chapter 16, you will notice they keep talking about z values. They're just saying that this x-axis now, this is a standard normal graph that is now called z value. So this is z value of 1, z negative 1. And that's beautiful because it talks about the standard deviation. Okay? If you have a graph that isn't that, okay, for example, the one I tried to do an example with the IQ stuff, your IQ question could be something like this. It might have been something like that, where the standard or the mean is 100 and standard deviation was 15. Right? What you wanted to do was you wanted to take this graph and compare it back to the original. Meaning that when z is 1, what should that correspond to for my x value? That's what you want to know. Because you want to know, if this is the width of 1, whatever that area is, let's say that was 68%, then what you want to know is, for it to be 68% as well, what should these x values be? See the difference that I'm using in terms of letters? I'm using x for these, I'm using z for these. These are the areas that you know. Your calculator only knows the z areas. They don't know this. So for what you have to do is you have to convert all this back here or convert this back here. To get your z values, to get your x, this is your main, this is the only thing you need to understand. That's a transformation. So if I want to convert it, let's say when z is 1, if z equals 1, I want to find x. If I know the mean is 100, and I know standard deviation is 15, I can work this out. I can say what x is. So x would be 15 equals to x minus 100. Therefore, x is equal to 115, which makes sense because that's what I said before. Standard deviation is 15. So from 100, one standard deviation across, it has to be 100 plus 15. Makes sense why it's 115. So what I'm saying is that x equals 115, that's equivalent to z equals 1. Okay, that's what I'm trying to say. So I'm trying to say, if you compare the two graphs, when x equals 15, z equals 1. So if you want to find the probability for z greater than 1, that's the same probability as x greater than 115. Because they're symmetrical, they're meant to be transformed. That's the transformation equation for it. That's all we're saying. Okay, so in your exercise or the exam questions I tried to get you to understand was some of the questions were doing things like find probability of x greater than 115. See, we don't know that. But what we can do is we can convert it, and what I just did was I converted when x is 115, that's equivalent to saying z greater than 1. You can do this on your calculator. So that's possible, as we know the z values. Okay? So exercise 16a, what are you really doing? That's the only exercise you're working with. It's just the transformation z equals to whatever your data is minus the mean divided by standard deviation. Yeah? If you want to go backwards, it's the same thing too. Alright? Now the only thing I'm going to add on for today's session is why do we want standard deviations? Why they're so beautiful is because there are three regions that we work with. Because it's symmetrical, one of the things they know as a fact is that, remember chapter 13 I introduced this idea. I said if you have x is between, so your variable, if you took your mean plus 2 standard deviations and you took your mean minus 2 standard deviations, I said this was approximately 95% of the data. Yeah? This is just the fact in terms of what they know. If you have the distribution, taking a standard deviation minus 2 and add 2, that will give you 95% of the data. Okay? Visually, this is what it means. That's your bell curve. If we're talking about a normal distribution, we're saying if this is the mean, standard deviation of 1. If I'm saying 2 standard deviations, I'm just saying when z is negative 2 and when z is 2, the area underneath the graph is 0.95. That's the first property. So these are your 3 areas that you need to remember. It's a 68, 95, 99.7. Okay, so when you have mu minus 1 standard deviation and mu plus 1 standard deviation, this is 68% of the data. If you have 3 standard deviations, it is 99.7%. These are the 3 properties that you must understand. So this carries throughout. Okay, so the only one I introduced was chapter 13, I introduced you to the 95%. In chapter 16, you now have just these extra 2 to add on. Okay, so when it's 1 standard deviation, it's approximately 68% of the data. Okay, and this is just across any kind of data you have. You can have discrete, continuous. It doesn't have to be normal. It doesn't have to be a normal distribution. It can be any data. If you get your data and you added 1 standard deviation, which is the error, minus 1 standard deviation, that width of that graph, the area or the probability of it should be about 68%. That's what they know as a fact. Okay, so you take it out 1%, 1 standard deviation to the right and left, that's 68. 2 of them makes it 95. 3 of them makes it 99.7. So copy that down, just make sure you understand those 3 properties. Okay, so that's what 16b is about. And I'll show you some questions so you can get a feel of it. But the theory for every one of them is the same. Area under the curve, it's a probability density function, and the only one thing you needed was that. That's all you needed. Okay? And you can do this all throughout chapter 16. This is all you're doing. You're either finding z, finding x, finding mu, finding standard deviation, or finding both. It's the same thing over and over. Okay? Alright. Any questions so far? That was chapter 13, 14. I haven't done 14 yet. I haven't recapped it again, but chapter 16, 15 is what I'm mainly focusing on today. We good? Yeah, let's do some examples. Here we go. So you got your 3. Those are your 3 extra properties. Let's have a look at part 2. Normal distribution, part 2, continuing from last lesson. Now, let's have a look at this question here. It says 68, 95, 99.7%, that's the one I just talked about. 1 standard deviation, 2 standard deviations, 3 standard deviations. Yeah? Rule tells us approximately the percentage of a normal distribution which lies within 1, 2, or 3 standard deviations of the mean. Now, if Z is the standard normal, okay, so I know all these words sound funny, but if you just break them apart, if Z, so you've got the Z axis, is the standard normal, which we already knew, Z values. Find corrected two decimal places of A such that PR of negative A, Z, where Z is greater than negative A and less than A, where it's 0.68. So if you visualize this, all it's saying to you is this. You've got a standard normal, mean is at 0, standard deviation is 1. This is your Z-axis. I told you before that if you took the mean, add 1 standard deviation to the right and minus 1 standard deviation to the left, that width should be 68%. So naturally, the answer to this has to be negative 1 to 1. That's it. Because you know that's your standard deviation. So if I were to just answer the question A, we're just saying probability of negative A less than Z to A. For it to be 68%, I know this has to be X plus 1 standard deviation and negative, or X is mu again, minus standard deviation. Mu, sorry. Okay? And our mu is 0. 0 plus 1 and 0 minus 1. That's why I have negative 1 and 1. Okay, so it's just using that 3 properties. So it's negative 1 to 1. My A is 1. Okay? What about B? Same thing, 95%. This has to be what? What will B have to equal to? Yeah, negative 2 to 2. 2 standard deviations. Mean is 0, because this is a standard normal. Obviously, in other questions, it's not a standard normal, but when it's a standard normal, it's beautiful. It's easy. You just add 1 or subtract 2. That's why it's easy. It's negative 2 to 2. And then obviously, Z, when you want 99.7%, then this would have to be between what values? What values do I have? Good. Negative 3 to 3. Simple as that. That's why we like the standard normal, because you have a mean of 0, 1 standard deviation describes it. So this is nice. The 68, 99, 95 and 99.7 is what we like. Okay? So, let's do some other questions now. Let's try it. Given that X, so now it's not a standard normal. So you know, they tell you. And in your exams, it's going to be the same thing. They either say standard normal or they say normally distributed. There's a difference between the two. So let's read this question. Given that X is a normally distributed random variable with a mean of 22, so now you don't have a mean of 0 anymore, and a standard deviation of 7, it's no longer 1. Find probability of X less than 26. See, it's the same thing. If you think about, picture it. Every one of these questions, I want you to picture it. So A, sketch it out. This is what you have. You've got a normal distribution. It's not the standard normal. The mean now is not 0. The mean is 22. Standard deviation is 7. They're asking you to find, if 22 is here, right, the center, less than 26, 26 has to be over here somewhere. So what are you trying to find? You're trying to find probability. Probability is the area under the curve. Then this is what you're looking for. All the way up until you get to 26. That's what you're really asking for. It says, if this is 26, that's my X variable. X less than that, what's the chances? What's the probability of this? So you know the total probability is 1. You want to know this. Now at this point, there's only one skill that you've got to use. What's that skill? What are you looking for? There's 2 ways to do it. But really, because you guys got a calculator now, it's simple and easy. Back then I had to convert every one of those to a Z value, but you don't now. See, on your calculators now, you can literally just type normal CEF, type in what the mean is, type in what the standard deviation is, and bam, you get your answer. Okay, so, wait, let me just rub this off so you can see. See, the difference between what I used to do and what you guys are doing now, that's what you have to do. You just type in normal CEF, YCEF, cumulative. You're adding all the probabilities up until you get to what you want. So negative infinity is starting on the left-hand side. Going all the way up to 26 is what I would want. What's my mean? 22. What's my standard deviation? 7. Back then I didn't have that. See, back then I had to convert, I only had mean 0, standard deviation 1, and then I have to work out what that z value will represent. So what I'm trying to say is, this is what your current graph is. You have this, and your mean was 22, standard deviation of 7, and you're trying to find the area from 26 and below. I couldn't do that back then. I couldn't just type normal CDF and get my answer as 0.716. What I had to do was I had to change it to the standard normal graph. And my question was, if this is 0, standard deviation of 1, my question was, what's that z value? See, so I had to convert 26 to what the z value is, and my calculator, or the z tables that I had, I can then calculate less than that particular value. But I couldn't do that. Okay? That's why we're trying to teach you the one skill. It was only z equals to x minus mean divided by standard deviation. So if I want to know what that z value that corresponds to it, x, which is 26, mean is 22, divided by 7. So if you work it out, this is what? 20, what's x was 26, take away 22, divided by 7. That's 4 out of 7. So I know this value right here is 4 out of 7. So on my calculator, on my table, I will go find on the table where is it less than. I want to find the area less than 4 on 7, and I could do that. You guys don't have to do that anymore, because your calculator will convert all that for you. They'll do it all for you. So when you type infinity 26, mean 22, standard deviation 7, it does it all for you. You don't have to do this anymore. But it doesn't mean you don't need the theory, because later on you still have to problem solve, and sometimes you got to convert. But that's just the one theory that you needed. Does that make a bit more sense? What you're doing, you're trying to convert every normal distribution to a standard normal. This is all the probabilities we know. We don't know this. The calculators do, but we don't. Okay? All right, how do we feel about that? Is that cool? Let's try another one. Let's do B. Actually, I'll show you what I mean with a calculator as well, so you can see both answers are the same. Alright, here we go. Menu 1. You want to do normal CDF, you can literally type norm CDF, and that's fine. Alternatively, menu 5, probability, distribution, 5 again, so menu 5, 5. You're doing normal CDF. So normal CDF, lower bound negative infinity 2. Now, see, if I have a standard normal, what I figured out before was Z was 4 out of 7. That's what I figured out before, right? So here I figured out it's 4 and 7. So I want my lower bound negative infinity all the way up until 4 out of 7. And I want to know what that area equals to. This area should equal to exactly the same area as that. Okay, provided I converted it correctly. Okay, so x is 26, means 22, standard deviation was 7. 4 and 7 should be correct, yeah? So now I'm going back, and I'll change this to 4 out of 7. And it'll do the same thing for you. See that? That's 0.716145, and that's also 0.716145. They're both exactly the same. One's just normally distributed, one is the standard normal. But they're both, though they have both different means and standard deviation, it's just a transformation, a dilation. That's why it's the same. Okay, so this is what I had to do back then. What you see there is what I had to do. What you guys can do now is type it all in one go, and you get your answer. That's the difference. Okay, but the theory is here, just that transformation is what we do. Okay, so let's try now. B, let's have a go with B. I want you to have a go with B. Same theory, same thinking. Think about the values, the 3 properties that you have. You're trying to find the probability of x is between 25 to 27. Picture it. Draw it if you need to. So if you draw it, same thing again. Mean was 22. Standard deviation 7. So you know 25 should be somewhere here, 25 to 27. You're trying to find that area there. So how do you do that? So that's what you want to find. That's what you want to do. And it's exactly like what you did in chapter 11, integration. You want to find the area between two curves, or between 2 points. How do you do that? 25 and 27. You can type that on your calculator too, by the way. Otherwise, back then I had to just find the area of 25 and then area of 27 minus the 2. Okay? But here we go. Calculator work. Simple and easy. 25 to 27. Mean 22. Standard deviation 7. Bam. Okay? It's the same drill over and over. Normal distribution. It's very easy if you understand the concept. Okay? Let's try D. D looks interesting. Let's go with D. How would you do D? Look at D. So C, find C such that x is less than a particular number, so picture, where the area is equal to 0.95. So what are we trying to find? Now got the area, we don't have the variable, we want to find the variable. How do we do this? It's again, it's only one step. It's only one step calculator work. You gotta understand what you're doing. What are we doing? So picture it.
Is it still part of that figure?
Alrighties. Answer the question. Yep. C is conditional probability, same thing. So yeah, I'll do C too actually. I'll do D and then I'll come back to C. So D, x less than C. C, because it's 95%, remember when you calculate anything less than a particular value, it has to start from negative infinity. So negative infinity, 95% has to pass the center. So the center is 50%. So 95 has to be somewhere over here. So I know the value has to be bigger than 22. So let's say C is over here. I'm just making it up. Let's say C is here. I know that the total area has to be 0.95. See, the beautiful thing is for you guys, you only got one calculator work. If you have an area, you have a standard normal, you have the mean and the standard deviation, you're set. That's the only three you need. Yeah? Area, standard deviation, and a mean. You can find the x value. If you think about it, that's all you really need. So, how do you do it? On your calculator. Menu. 5. These are the only two that you're going to use for chapter 16. One was to find the area, then one is to find the variable. You only got one, it's inverse normal. Inverse normal allows you to find it. So let's have a look. Inverse normal, here you go. Area, you know you want it to be 0.95. The only one thing you have to remember, when you're using inverse normal, it always calculates left to right. Okay, it doesn't do between like A and B, it only calculates left to right. In our case, we're fortunate, it is from left to right. We're going from negative infinity up to a certain point, and they will calculate for you what that value is. Okay, so you know the mean? 22, standard deviation, 7. Voila. Bam. That tells you the x variable. So it has to be 33, which makes sense. I said it had to be bigger than 22, and it is. So if x is less than 33.5, that should give me approximately the area of 0.95. Okay. Let's have a look at C again. Let's look at C. Let's look at C. So, damn, I should have animated that. Conditional probability. Back to chapter 13. Conditional probability. Chances of A given that B had occurred. So that's what I'm writing here. That's chapter 13. A given B, so it's out of B, probability of B, which is the chance of 25 to 27. We figured it out before in part B. Yeah, so in part B, we already got the probability of that. That's what we want. Okay, which is really this. What's the probability we don't have? So let's think about what we don't have. It says chances of A and B occurring. Now don't get intimidated by all these like letters, but read it. This says when x is less than 26, when will that intersect with 25 to 27? So if you actually draw it out as a number line, I said less than 26, which looks like that. And the other one says between 25 to 27. So where do they both intersect? That's where they both intersect. So when you say what's the chance of both of them occurring, for them to be less than 26 and they intersect with 25 to 27, then clearly it's between 25 to 26, right around here. Okay, that's the logic. Because you're just saying, when do they both occur? Well, that's where they both occur, right here. So I'll just highlight it for those who weren't listening. Whoa. This is where they both occur. That's why it's between 25 and 26. Okay, and you can find out this probability using normal CDF. Lower bound, upper bound. You got your mean, you got your standard deviation. Sub it all in, and that's how you get your answer. So normal CDF 25 to 26. Mean, standard deviation. This one you already had from the previous answer, but there you go. How do we feel? Does that feel easy? That was 16B, 16C, 16A, sort of summarized. Okay? I think on Wednesday or Thursday I'll start practicing chapter 14 and 13 again for your SAT. Okay? But revise! We're almost there. It's almost to the end, guys. There's about probably 6-7 exercises left and I'm done. Do all. Do sample. Yeah. Oh, no. It's just 13, 14, 15.
But we do sampling, and that's sort of